Looking at the Math 2 Chapter 5 practice test. We start with our first problem. Find the sum of the measures of the interior angles of a 17-gon. So we want the total for the interior. Our rule is n minus 2 times 180. We go 17 minus 2 times 180. That gives us 15 times 180, which is 2,700. To find the measure of each exterior angle, we want each one, so we want the individual. We know the exterior total is 360. If it's an octagon, it has 8 sides. 360 divided by 8 is 45 degrees. Find the number of sides. So number of sides in a convex polygon whose interior angle sum is 3060. So here we go, 3060 equals n minus 2 times 180. If I divide 3060 by 180, I get 17 equals n minus 2. I then add 2 over and I get 19, so that would be a 19-gon. For number 4, find the number of sides for a regular polygon where the measure of each exterior angle is 7.5. Well, we notice that 360 is the total. It's going to be 7.5 times the number of sides that we have to get you 360. So if you divide 360 by 7.5, we get n is 48. So it is a 48-gon. Number 5, we're solving a hexagon here. A hexagon is 6 minus 2 times 180. To get the total, that comes out to be 720 degrees. So we say 720 equals 120 plus 95 plus 120 plus 125 plus x plus 84, and we're solving for x. Now should have 2 x's there. Oops, I've got an x. So it's 720 equals 2x. I'm going to add up these values, 84, 120, 95, 120, and 125 to get 544. We now subtract 544 from our total, divide it by 2, and we get that x equals 88. For number 6, we need to find the value of each variable in our parallelogram. So I can set these two equal because they're opposite sides congruent. I can set those two equal, opposite sides are congruent. 6x equals 3x plus 15 becomes 3x equals 15 and x equals 5. Y plus 5 equals 2y minus 10 gives us y minus 10 on the right, 5 on the left. Add 10 over, we get y is 15 and x is 5. For number 7, we have a kite. Now for the kite, we have adjacent sides are congruent. So we can go 3x minus 7 equals x plus 7. I'm going to subtract x over and get 2x minus 7 equals 7. Add the 7 over, 14, so x is 7. I also have these opposite angles are congruent. So we'll go 4y equals 2y plus 60. We get 2y equals 60. And y is 30. And lastly we can do is classify, that is a kite. For number 8, this is going to be a trapezoid. In fact, an isosceles trapezoid because base angles are congruent. So I'm going to go 10x plus 15 equals 15x. That becomes 15 equals 5x, and x is 3. For number 9, we need to find the length of the diagonals in a square. Now, AE is this portion. BD is the whole thing. So our option is to take half of BD or double AE. So let's just double AE. So 2 times 3x plus 5 is really 2 times AE, which is AC, which is equal to BD. So by doubling that, 6x plus 10, I can say 6x plus 10 equals 10x plus 2. Subtract 6x, subtract 2, 4x equals 8. So x equals 2. But they want the length of the diagonals. I can plug that into either of these. I'm just going to plug into there. So that's going to be 10 times 2 plus 2 is 22 units. For number 10, can we conclude if it's a parallelogram, rhombus, rectangle, or square? Well, we know it's a parallelogram. They gave us that. Since the diagonal bisects angles, that's going to tell us we're going to go rhombus. And that's because we have 41, 41, 41, 41. Now, if the 41s added together to be 90, we would say it could be a rectangle. In that case, it would also be a square. But since we only know that much, we're going to stop at rhombus. For 11, we have angle CAD in the rectangle is 43 degrees. We need to find all other angles. Now, I know in a rectangle that diagonals bisect each other. They're also congruent. So if that's 43, I also have a 43 here. We can also use the fact that the angles add up to 90 degrees. So this is 47, which we can match over to 47. 47 here matches to 47. Then we go 43, 43. Last thing we have is those central angles. Now, 43 and 43 is 86. 180 minus 86, because it is a triangle, is 94. We have its vertical angles 94. Then the angles next to those is 180 minus 94, which is 86. For number 12, QRST is an isosceles trapezoid, so we'll mark that as such. If we know that, we have same side interior angles here, so that's 180 minus 116, gives me 64. And then I can go across to the other side, and that's going to be congruent angles because it is an isosceles trapezoid. So we would say that Q was 64 degrees, T was 64 degrees, and S was 116. For number 13, we need the mid-segment of our trapezoid. Now this mid-segment is equal to the average of the bases. So 12 equals 5x minus 4 plus 8x plus 2 divided by 2. That's finding the average. To clear out the 2, I'm just going to multiply the 2 over, make that 24 equals 5x minus 4 plus 8x plus 2. This is 24 equals 13x minus 2. We get 26 equals 13x, so x is 2. We could go back, check our answers. Up here, that becomes 6. Down here, that becomes 14. And if we look here, oops, that should be 16, that'd be 20. There we go. 6 and 20, 12 is in the middle. It is for the mid segment. For number 14, we have a kite. We need the measure of angle RPT, which is right here. Now in a kite, I know diagonals are perpendicular, so this gives me two right triangles between these two. They're congruent by a reflection. So if I have 90 here and 34, 90 minus 34 gives me the other angle, which is 56. And I can go across to angle RPT, which is also 56 degrees. For number 15, we need to classify as precisely as possible. This will be a kite because it has adjacent sides congruent, but not opposite. I should say two sets of adjacent sides congruent, but not opposite sides. We have the two sets here, two sets here. Now this one, I got diagonals bisect each other, so it could be a parallelogram, but they're also perpendicular. So the fact they're perpendicular makes this a rhombus, and that's because I have diagonals perpendicular and they bisect each other. Now if I just had the bisect each other, we would stop at parallelogram, but since we qualified it as a parallelogram and we could go forward to make it a rhombus, diagonals perpendicular works for us. The last one here is a square. That's because I have 4 congruent sides and 4 congruent angles. The congruent sides qualify it as a rhombus, the congruent angles qualify it as a rectangle. Rhombus, rectangle gives you square. For 16, I have some points here. I need to find point M. Now if I notice in my parallelogram, it goes A units over. So up here to get to N, it went A plus B to get the whole distance. Well, this distance here is still A, so in fact this little part right here is going to be B. How much I went up is the same, that is C. So now I want to find the midpoints of the diagonals. We draw these in. The midpoint of, we'll go MP, is add the x's, divide by 2. That's going to be a plus b over 2. Add the y's, divide by 2, c plus 0 over 2. We get a plus b over 2, c over 2. Now for our other point, we'll call that ON, with the midpoint, we get 0 plus a plus b, or just write a plus b over 2, and then 0 plus c over 2. We get that midpoint. Now we notice these two things are the same. That means that the midpoints are the same point on each diagonal. That would indicate that the diagonals bisect each other. And that is one of our properties to get a parallelogram. For 17, I'm going to plot some points here. I got back one, up one is 1 point. Over 1, up 4. Over 5, up 1. And 3, down 2. Let's just approximate right there. So I have my shape here. I'm going to write in the coordinates. Now, one way we can go and show this is a parallelogram is show that opposite sides are parallel. To do that, I'm going to look at their slopes. So this slope here, it went up 3 over 2, so that's 3 over 2. Down here, it went up 3 over 2, that's 3 over 2. The slope for this side, it went down 3 over 4. Here it went down 3 over 4. So I see I have slopes of -3, 4, and 3 over 2. So we know opposite sides are parallel. That means we got a parallelogram. Another option is to look at diagonals bisect each other. And that's where we're going to take midpoints. So we're going to go use these 2 points. We get 1 plus 3 over 2, 4 minus 2 over 2. This gives us 4 over 2 and 2 over 2. So our answer is 2, 1. And our midpoint for these two is going to be -1 plus 5 over 2 and 1 plus 1 over 2. And this becomes 4 over 2, 2 over 2, which is 2, 1. So the fact the midpoints are at the same point, it tells us the diagonals bisect each other. The final option you could do is use distance formula, but that would be a little bit messy. I would go through and just show opposite sides parallel, or even that fact that diagonals bisect each other. Now we're looking at the classifying quadrilaterals practice. So we need to determine the best classification for the quadrilaterals we have listed here. Do not fall for the "it looks like it" trap. We need to make sure that the reasons that are labeled is the reasons we can go by. So I look at our first one. I have one set of parallel sides, so that tells me it at least qualifies as a trapezoid. And then these two angles congruent would be base angles congruent. So our reason is it's an isosceles trapezoid because one set of parallel sides qualifies as trapezoid. Base angles congruent gives you isosceles. Second one is a square. It's got 4 congruent sides, and it has 4 congruent angles. And we know, even though we have the 3 right angles, we know the 4th one has to be a right angle because, first of all, the angles add up to 180, or add up to 360, so you have 90 left over. You could also go by the fact that you have all the sides the same. It qualifies it as a rhombus, which also means a parallelogram, which means opposite angles congruent, which could also work. So we're going to go square. Third one is a rectangle. We know rectangle because we have opposite sides parallel, qualifies it as a parallelogram, and then these markings tell us diagonals are congruent. Next row, it's going to be an isosceles trapezoid. And that being because we have one set of parallel sides qualifies it as a trapezoid, and then the base angles congruent, the 115s and the 65 make it isosceles. Next one will be a parallelogram. And all we know here is that opposite sides are congruent. I have 2 sets that match, makes it a parallelogram. We now go Isosceles Trapezoid. This one is the same as the one on the other side. You just have base angles marked. These are actually all three of these are the same. Next shape on the next row is a kite. This has two sets of congruent sides, adjacent sides, but not opposites. We really just need to be able to identify a kite, and that right there is a kite. Next is a rectangle. We have diagonals bisect each other, which qualifies it as a parallelogram, and the diagonals are congruent, which makes it a rectangle. Here's our markings there if you can't quite see. Following one will be a square. Our reason for a square, it needs to have something from a rhombus and a rectangle. Well, first of all, we know it's a parallelogram because the diagonals bisect each other. We know the diagonals are congruent, similar to what we looked at on the previous problem, which makes it a rectangle. We know it's a rhombus because it has right angle there, and that means the diagonals are perpendicular. So it's a rectangle, a rhombus. We say it's a square. Next row, our first one there is a square. All four congruent sides, four congruent angles. Pretty straightforward. Next is a parallelogram. Opposite sides being congruent is one of our rules to qualify as a parallelogram. Following shape is a parallelogram. This has opposite sides parallel, both sets. Next, it's going to be a trapezoid. We've got to be careful on this one. These two add up to 180, which means these two sides are parallel because of the same side interior angles being supplementary, which qualifies with the parallel. Can't go further. We can't say A and B are the same or C and D, so we're just going to say trapezoid. Following one is also a trapezoid. One pair of parallel sides. Last one in this row is going to be a quadrilateral. It's got one set of sides congruent. It does not have the other set. If I had these two sides were parallel, that could also work as a parallelogram, but we don't have enough information. That one, we're just going to say quadrilateral. It's going to be a parallelogram. One reason is that both sets of opposite sides are parallel. Could also just look at these, and that's that sixth rule that we have to make a parallelogram, the fact that the one set of opposite sides are congruent and parallel would qualify it. Our next one is a trapezoid, and similar to what we did here, these two angles add to 180, they're same side interior, so that makes our set of parallel sides there. It's not isosceles, but it's a regular trapezoid. Rhombus, for the last one, the diagonals bisect, which qualifies it as a parallelogram, but they're not congruent, which makes it no rectangle and no square. Why we're going to go rhombus there is that you have the diagonals are perpendicular, qualifies for a rhombus. Now, moving down, mark X, the box that fits the property. Both pairs of opposite sides congruent is a parallelogram. Both pairs of opposite angles congruent is a parallelogram. And the last one, consecutive angles supplementary, is also a parallelogram. Now, why I looked at those first is those are properties that qualify us to a parallelogram. If it works for a parallelogram, it works for every shape within that parallelogram family, which means these three all apply. Now, if it was a rule for a quadrilateral, then it means all of these would apply because they're all within the quadrilateral family. But we know those. Any of these are not going to work for the kite and the trapezoid because they're not in the parallelogram family. So we go to the third one. Exactly one pair of opposite sides congruent. Now, that one's tough because we know it's not a kite. Sides aren't congruent in a trapezoid. What that actually applies for is an isosceles trapezoid, which we didn't write there. We're just going to add that on and make that an isosceles trapezoid because, well, we can. Otherwise, it doesn't apply for any of them. Exactly one pair of opposite sides are parallel is our definition of a trapezoid. Exactly one pair of opposite angles are congruent. That one, if we draw it out, is going to apply for a kite. It's not one we talk about too much. We really don't do much with kites, but that is a property that you have. It's not both sets of angles, but it's that one pair when you look at the diagonals. Now, this table was kind of incomplete. Let's look at this one. So here we have more properties. We have our parallelogram, rectangle, rhombus, kite. Let's go and fill out what we got. So first thing I'm going to do is I'm going to go through and mark in all my parallelogram properties. So 2 pairs of opposite sides parallel, 2 pairs of opposite sides congruent, diagonal forms 2 congruent triangles is one that works for a parallelogram. We can go like side, side, side for that congruence. Diagonals bisect, opposite angles are congruent, and consecutive angles supplementary. Why I did that first is then I know all of the rest of those automatically work, and I don't have to worry about them. Now, most of the time, when it applies to one of these, trapezoid and kite do not apply either. 2 pairs of opposite sides parallel is what makes it a parallelogram, so those are out. Now, it has exactly 1 pair of parallel sides is our definition of a trapezoid, so we'll mark that one. 2 pairs of opposite sides congruent, that one's taken care of. Has 2 pairs of consecutive congruent sides, but opposite sides are not congruent. That was our definition for a kite. All sides congruent. Where does that show up? So if we look at that table we had that kind of followed the chart, all sides congruent shows up at a rhombus. If it works for a rhombus, though, it works for a square. Diagonals congruent shows up in a rectangle. So we mark that first. If it works for a rectangle, it works for a square, not a rhombus. Be careful on that one. Diagonals perpendicular, that shows up in a rhombus, so also a square, but also a kite. Diagonal bisects 2 angles. That's going to be a rhombus, which is also a square. Now, this one's tough because it's one of the diagonals in a kite, but not both. So it's kind of an appearance property. Maybe ones that have to solve for angles, but not all of them in a kite. Diagonal forms 2 congruent triangles. Not in a trapezoid, but in a kite, if you drew the long diagonal, you do get 2 congruent triangles, so we'll mark that one here. Diagonals bisect each other, is taken care of. Opposite angles congruent is taken care of. All angles are right angles. First shows up in a rectangle and also a square. Consecutive interior angles are supplementary. What's tough about that is you have some angles in the trapezoid that are supplementary, but not all angles. So since you only have that 1 pair of parallel sides, not all of them, it's sometimes for those.